All right, so good afternoon, everybody, and thanks for tuning in. This week we are going to be talking with Vas from Globus, and he is going to be doing a presentation on automating research with Globus. So I'll turn it over to you, Vas.
Great. Thanks, Jason. Thanks, everyone, for joining. Jason said I'm with the Globus team at the University of Chicago. I'm making the assumption today that most, hopefully all of you, are aware of Globus. I'm not going to spend much time introducing what Globus is and what it does, but I will put up one of these sort of summary slides, if you will, a little bit of an eye chart, but just to point out that Globus is essentially a service for managing research data throughout the life cycle. And at its core, it has a reliable, high-performance file transfer mechanism, right, based on grid FTP. And then we've added to that the ability to share, which allows you to share data with external collaborators outside of your institution. In other words, people that don't have local accounts on your systems, allows you to do that sharing directly via Globus without having to move data and create local accounts and so on. And it also provides a more formal data publication capability where you can attach metadata and so on and make things available. And for the most part, users that sort of come to Globus for the first time will end up using a web browser. All of this functionality is available just via a browser. They can access any storage, meaning any storage system that has the Globus Connect client on it, which I'll talk about a little bit later on. And in many cases, they can access these systems using their existing institutional identities. So I could log into my campus cluster at the University of Chicago just using my UChicago ID via Globus because of the whole federated identity system that Globus provides. So that's sort of the super high level from sort of a beginning user perspective. But what I want to focus on today is how Globus can help folks automate common research flows. So probably the most common one is, hey, I've got a bunch of data that is on my lab server or somewhere on campus where I want to back it up or I want to move it somewhere else or create another copy, what have you, right? And I want to do this on a recurring basis, right? Maybe I'm running experiments on some kind of schedule, and after every experimental run, I want to move my data and back it up somewhere, right? So I can schedule this. I can, create a cron job that calls out to Globus and does all of this, and just sort of rest assured that Globus will, reliably move that data and back it up, right? A very common scenario, we're starting to see more and more of this. It started out with, people using big shared resources like the advanced light source or the advanced photon source at Argonne. Increasingly, we're seeing other high-res instruments like cryo-EMs and things like that coming online. And obviously, there's the whole, swath of next-gen sequencers pumping out terabytes of data a day. So in most of these cases, you have to have some way of getting the data off these instruments quickly and reliably. And quickly because these are, again, shared resources and you've got lots of other people standing in line to use them. So Globus provides a really nice way of automating sort of the egress from these instruments, from their sort of local storage, which is typically very limited, out to whatever other storage system you want to stage it on so that you can do downstream analysis and so on. And sort of following on from that flow, right, I may be running, whatever analyses I have on some kind of HPC or high throughput computing resource. And then what I like to do is take that resulting data set and distribute it out or share it more broadly with perhaps my project collaborators or maybe even the broader research community if I want to make some of these results more publicly available. And you can do this, again, directly via Globus, where you create shared endpoints, as we call them, and I'll show you how all this works in just a second. But more and more what we're seeing is people developing, or they already have some type of portal or science gateway that users come to do all sorts of other things around that project or that discipline, and would like to give them the ability to make their data available via that same application, portal gateway, what have you. So I'll show you an example of something that we've built that does exactly that, and actually uses the Science DMZ as a way to maximize the data throughput. And then, as most of you are probably aware, there's sort of mandates to have data management plans from all the agencies. There's also a mandate more recently from, I believe it's the NIH, where everyone has to have a data sharing plan. So they're sort of going even beyond just, store the data somewhere. It's actually make it available to others in some meaningful and easy to access way, right? And so you can use the same mechanisms that I've just talked about to assemble data from multiple sources, put it into some kind of repository, attach some metadata to it, and then at the end of that, actually assign some kind of persistent identifier that you can then share with others. So that's sort of, again, throughout that whole research workflow, the more sort of common tests that we see, and there are ways to automate this. But before I jump into what that looks like, I just want to sort of level set everyone on how Globus operates. So Globus is it's hosted, it's software as a service. We run a single sort of global instance, if you will, on Amazon. And what Globus does, it acts as a third-party manager, so as a controller, as you can see by these dotted lines here. It controls the endpoints where the data live, and the data flows directly between those endpoints across what's called the data channel. So there's no staging of the data on Globus. We don't provide any storage. We don't relay data through us or anything. So data flows directly between the endpoints, and Globus controls it. And then in the ideal case, or the best practice deployment, and many of you have probably seen this slide in one of the ESNet presentations or workshops, where you actually have those data transfer nodes actually sitting in the Science DMZ. So you have sort of well-provisioned data transfer node that's tied to a nice, clean, wide data path that's not going through enterprise firewalls and so on. So Globus is talking to those endpoints, again, through a different set of channels, but the data is actually flowing across this nice high-speed path. And then as far as sharing, the way that looks, just at a sort of a conceptual architectural level, the user who has access to the data creates essentially a set of permissions that overlay those that are on the actual file system itself. So you as an administrator obviously have ultimate control over who can do what on your storage system, but Globus allows the user who already has access to the data to create the shared endpoint, as we call it, and create these overlay permissions that then grant access to other external users who don't have local accounts on the system where the data live. So this is a really powerful mechanism. And again, it's by no means a way to bypass security, right? The only way you can share is if you already have access to that data, and if your administrator has allowed you to share data off that endpoint. So this can all be done via the browser, but more importantly here, we're going to talk about how you can automate some of these. Just a quick detour to talk about what these endpoints look like. So if you like Globus to be enabled on your storage system, you use this piece of software called Globus Connect Server. It installs a set of packages, most importantly the GridFTP server, which handles the data movement, and then some security bits, and allows anybody who has a local account on that system to then access it via Globus. And we have, by default, that system supports sort of POSIX compliant file systems, but we also have these add-on non-POSIX connectors that you can use. We continue to add to this list. We're going to have another one announced at Supercomputing in a couple of weeks, and we've got some others in the pipeline, like Box. So that's the way you sort of expose, if you will, make your storage system accessible via the Globus service that others can get to. So now let's talk about how we integrate some of these flows in a more automated fashion. So beyond the web UI, we have even more functionally complete, if you will, full-featured command line interface. So I'm going to switch over and show you what that looks like. So anything I can do via the web UI, I can do via the command line. Oops, go back here. Right, so this is modeled after the Amazon CLI, if you are familiar with that at all. So it's a set of Python scripts, right? So instead of AWS, I'll type Globus. There are the commands that I have access to. I can do things like show a bunch of endpoints. So let me just use my cheat sheets here, so I'm not typing. Right, so let's say I wanted to find all the ESNet endpoints that have read-only in them, right? So I'm searching for ESNet, read-only. That's the 4 or 5 endpoints that ESNet maintains for testing purposes. Some of you may have used those in the past. And let's say I wanted to find an endpoint, which I actually set up a little earlier here for the purposes of this demo. So I can do things like, filter the list of endpoints to only those that are administered by me right here. And there's a whole bunch of different filters that I can apply, as well as search criteria. And this is important because we have, at this point, over 50,000 endpoints that are registered with Globus. And you want some fairly robust way of identifying the exact endpoint you're looking for. Again, in an automated fashion, so that you can get to, very importantly, this endpoint ID, right, the unique ID that you can then use in your scripts, right? So presumably, if you're going through the CLI, you're scripting, or you're adding these commands to maybe existing scripts to do something like transfer some data. So here I've got a pre-canned one, right? So what this, let me just make that a little bigger. So what this will do, this command here, right? It's going to run the transfer command, and it's going to copy from a source endpoint from that directory to a destination to that directory recursively and give it a label so I can identify it. So I'm just going to set the source equal to the ESNet endpoint here at Berkeley. So let's just do that. Right, I'm going to set the destination equal to my demo endpoint here. And then I'm going to run this command. Right, and so I've just sent a request to Globus saying, move this data. So it's queued this task. It's going to start executing. It's giving me a task ID. So I'll get this back, and then I can use this to go and query the status of that task, right? So at this point, if I actually switched over to my browser and looked at activity, right, I'll see that here's the transfer that I just started a few seconds ago. That's the same task ID there. So I can access this information again through multiple interfaces because they're all basically talking to the same backend service that the Globus provides. So that's just a very simple demonstration. Again, you can do things like create shared endpoints and grant permissions on those shared endpoints to other users, and then drop data on those endpoints so that they can go access them. I'll show you an example of that using the API directly next. So let's talk a little bit more about that. So underlying everything, as I said, is a set of core services. And so we've wrapped around those a set of APIs, so essentially a platform that you can use to build some of these science gateways and portals, or to integrate those capabilities into existing web apps and gateways and so on. Right, so at a high level, there's really 2 main services available right now through these APIs. There's the Transfer API, which is all the transfer sharing, task management, all the things that you would do through the web UI, and what I just showed you through the command line interface. Those are all accessible via that API. And then there's the Globus Auth API, which is all the authentication, authorization, sort of identity management related capabilities. That's the subject of a much longer talk. For those that are interested, I'd be happy to answer questions about that. But I just wanted to touch on a couple of examples of where this is being used. So this is one instance where the RM Climate Research Facility is using Globus as one of the options for distributing data. So if you see down here, sort of on the bottom right of the screenshot, Globus is an option for delivering the data. What happens is if the user, the user goes and searches for the data set they want from the, many petabytes of data that ARM stores. Once they have that subset of data, they check the box, submit the data request. What happens then is Globus, this application goes out, creates a shared endpoint on the ARM infrastructure. It puts that subset of data there and grants permissions to that user, and the user gets sent an email with a link to that data, and they can just click on it and download it. And that's all done behind the scenes. There's no need to manage all this stuff manually. Typically in the past, you might be doing things like, copying data somewhere, creating a temporary account, and having to monitor what the user's doing if they're downloading it. What I could do with Globus and with both the command line and the REST API is do things like check if the user has downloaded the data, and if they have downloaded it successfully, I can then clear that staging area. Because presumably that kind of resource is fairly limited. This is another instance where automation has been even more tightly integrated into workflows. So Wellcome Sanger Institute in the UK provides this imputation service, and all of the sort of infrastructure around it for accessing the service and moving your data into and out of the service is Globus-based. So you can see here you actually log in with the Globus credentials, or your own credentials via Globus, I should say. You submit your request, your imputation job, if you will, and then you upload your data, and that's all done automatically by calling into the Globus REST API. So just a little bit more detail on the REST API. It's a pretty standard sort of REST approach, right? So we have a bunch of resources named by URL. We use JSON documents, to pass, input and return results from the API calls. And very importantly, it's a secured API, right? So all requests are authorized via an OAuth2 access token. So this uses the Globus auth mechanism to get a token that you can then turn around and call the API with. I'm not going to bother with this. I'm going to quickly show you what that looks like. Actually, I have a Jupyter notebook where we used to experiment with some of this. And by the way, all of this code that I'm showing you here, this is all openly available on our GitHub repo. I'll share the links when I send Jason the slides here. But the idea is you can talk to the API programmatically, as you can see here. I'm not going to harp on the details of the code. The most important thing is that you are authenticating, getting an authorization code back, which you exchange for a token, and then you create this transfer client. And this transfer client is sort of your handle into the Globus transfer service, and then you can use this to do pretty much anything on the service that we do today, for instance, via the web API. So what I could do, for instance, is go down to, let's see, I've got an example here to transfer files, right? So down here, I've got a transfer, right? So I'll use those same two endpoints. This is the ESNet endpoint, and this is my brown bag endpoint. So I'm going to do the same transfer via the REST API. So I'm just going to hit Shift Enter to run that, and it will return this task ID to me. So Globus has accepted this transfer request. So I go back to the UI and look at activity. I should see 2 transfers going. That previous one is still running. And again, for those that are not as familiar with Globus, it's an asynchronous thing, right? So this is running, and it's only going to bug me if something goes wrong that it can't recover from, right? This hopefully hasn't run into any issues. But if it runs into problems, Globus will sort of work through those automatically for the most part. But it may come back to me if it needs, say, updated credentials or something like that, right? And so that's doing a transfer. If I wanted to then turn around and do what I just described in that one example, right, which is create a shared endpoint, right? So I can create a shared endpoint, and let me just change the name here. Where are we? So we create this to webinar share, right? So I'm going to create a shared endpoint on that target endpoint, on that destination endpoint into that directory. So what this is going to do is it's going to share just this /tilde/data1 directory with whomever I wish to share it with. So when I do that, right, creates a shared endpoint successfully. I'm just going to run through here, through some of these things, and then show you where I actually add people, grant people access, right? So down here, I add an access control rule, which basically says grant, in this case, read-write access to everyone in this tutorial users group. So I've set up a group somewhere in Globus for tutorial users. So anybody who is a member of that group can now get read-write access to that directory, right? So if I go switch over to my web UI and show you what that actually did for me is, if I go here and look for, what do I call it, webinar share, right? So I created this endpoint. It's again, this is like a virtual overlay on top of the storage system, where I can then go and drop data in, and then you can see here tutorial users have read and write access on this endpoint. So they can just come in and access it. And what this will have done is, if I share it with individual users, they will get a link saying, hey, this data is available for you to download, and so on. So that's just a very quick, high-level tour through some of these capabilities. I could present more stuff, but I think I'm just going to pause there and try and take some questions, because I know we want to wrap up in about a half hour. So fire away.
All right. Well, thank you, Vas, for giving us the quick overview. And I don't see any questions yet, but we'll pause for a minute. So I'll start off with one. When you're trying to convert, or you're working with researchers to sort of convert, and most people use something like an rsync-like syntax, how long would you estimate the actual hand-holding work would it take to sort of use sort of their old rsync-like syntax way of doing things for managing transfers to moving to something like this? What's the actual man hours required to sort of convert that workflow?
I guess obviously the answer is it depends, but at its simplest point, it's doing two things. It's ensuring that you have the right endpoint configuration, right? So there's some sort of one-time setup that you have to do on the endpoint side. Install Globus Connect server, do all that. The hardest part behind that usually is getting the right firewall set up so that Globus the Globus control channel can be enabled. So that's usually by far the sort of the long pole in the tent, if you will. Once that's in place, switching out a few lines in your script to call out to the Globus via the Globus transfer CLI call, that's literally very trivial. The bigger part, as I say, is really getting the endpoint set up right.
Okay. So we did have a question come in from Jorge. What encryption algorithms are supported by Globus, and does it support IPsec?
So the encryption is determined by whatever you have, whatever ciphers and things you have configured on your OpenSSL stack. So GridFTP, the way the encryption works is, and I'll show you. I'll pop out to that and show you where you actually check that. So there's a box down here. If you're going through the web UI, you can choose to encrypt the transfer. What that'll do is it'll make GridFTP call out to OpenSSL before it puts data on the wire. So it's really up to you to as far as how you configure all that.
Okay. And I have I guess a related question. Since I've heard people ask this before, what sort of is the hit, so to speak, to performance when you enable some of the encryption on top of it? What will be sort of the difference in performance levels for doing encryption versus non?
With the fast processors we have today, I mean, it really is a small fraction. I don't think we've actually sort of benchmarked it, but it's really not very noticeable. The one thing that does add more overhead, sort of percentage-wise, if you will, on transfer throughput is this verification. So this flag that's checked by default here, that's the thing that arguably sets Globus apart from sort of many other transfer tools. If you uncheck that, yes, your transfer will be faster, but you are running the risk of dropping some bits somewhere and having some integrity issues. So this is the thing where we go and do pre and post transfer checksums on the files, and that does add some overhead. Again, I don't have specific numbers for you, but you'll see, especially if you get retries because of multiple retries because of a failed file or failed set of files, that can add up, and sort of overall throughput will sort of go down on aggregate. But that's, yeah, the encryption doesn't add that much as a proportion of the transfer time.
Okay, thank you. So we have a question from June. Lots of scientific instruments can only be managed or controlled by a PC with Windows. To move collected data from instruments using Globus, I was told that SMB mounting with separate Linux server with Globus Connect server is the usual solution. Is this correct? If so, is it better to have the actual disk on the Windows PC or on the Linux server with Globus Connect server?
Okay, so let me break that apart a little bit. So to the first question, yes, that's one way to do it, using SMB mounts, but there is another way I've seen done in a few cases where the instrument, the PC attached to the instrument, actually there's a shared account where that's the thing that runs Globus Connect Personal, and then moves it to some locally sort of additional storage that's attached, that is then Linux based perhaps. And so that is actually, I would say, a better model if you can go that route. So take it off the sort of instrument staging area, put it onto some other storage, where you can then do things like automatically create shares for multiple users and so on, so they can get to those with their existing campus identities.
Okay, and we have a question from Greg. Is there information in the online docs concerning audit logging or authentication of user actions?
So we do log, obviously, that activity. It's not available to admins directly. So one of the things we're doing right now is actually we're going through a much larger exercise to become HIPAA aligned. Some of you may have seen a note we sent out yesterday, I think, related to that, sort of starting to put the steps in place to move all our infrastructure into VPCs that are sort of on Amazon's protected data cloud and things like that. So as part of that effort, we are going to be adding a lot more capabilities as far as making audit trails available, and additional historical data that's required to meet some of the HIPAA requirements. So right now, that's not something you can get at directly.
Okay. And Brian points out that if anybody is interested in more on June's question, you can look at Steve Wallace's project on the IU Mini DMZ, which is it's a good recommendation, Brian. So while we are waiting for a couple more questions to come in, I'll ask a selfish one just because I want to know the answer, even though I've seen the demo before, but I think everybody else should. Could you show us a little bit about the integration with Google Drive? Can you do a quick demo on that or talk about it?
Yeah, sure. So so we announced that we support Google Drive a few weeks ago. Kind of an interesting discussion going on there. Essentially, the way it works is with Google Drive, you set up what we call sort of a gateway. That's where the Google Drive connector runs. So here I'm showing you mine, and then you can say which users, in other words, from which domains can actually access that gateway and connect their Google Drive. So I've got a Google Drive demo endpoint which talks to my University of Chicago. Oh, let's see. I don't think I've got that gateway set up correctly. Hang on a sec. think my Google Drive stuff is down, Jason, but let me see if I can get to it. Google Drive. I guess I get to my UChicago, right? So that's my UChicago one, right? So if I go to my drive, you'll see that this is, I guess just, well, there's nothing in there right now, but it basically looks just like another endpoint, right? So, you know, it's the usual things you see when you go to Google Drive via the browser. So it's just, you're running, the way it looks conceptually is, I'm trying to find the slide for that. Conceptually, the way it looks is you have a data transfer node. So if I go back to this slide just briefly, this data transfer node has another component sitting sort of, if you will, underneath the Grid FTP server. That's the Google Drive connector. That talks out to Google Drive. So it talks HTTPS out the back end, if you will, right? Because we're doing puts and gets because Google Drive is essentially an object store. And then on the other end, it's talking Grid FTP as per usual. So that's how that works. I will, since we're on that subject, for those of you that do want to try out Google Drive, you should be aware of certain limits that Google imposes. One set is well documented, which all there is their API rate limits, right? So they only allow you by default to, make, I think 100 calls per minute or something on the Drive API. And there's a few other rate limiting things that they do to prevent, denial of service and all that, those kinds of things. There is also, it's apparently undocumented limits on volumes that you can dump on a daily basis. So we've heard that some people ran into a limit of 750 gigs per day, and then their account gets locked out. So we're actually meeting with the Google team next week at EduCause to try and work through some of these things, because when we first talked to them, they showed a lot of surprise that people might actually use Google Drive to dump tons of, terabytes of research data onto it. So stay tuned. That's an interesting ongoing discussion.
All right, great. Thanks for that update. I think that feature in particular, we've seen a lot of our users are gravitating towards it, not just for their research data, but also just for backups. So we'll pause for a minute here, and if anybody has any other questions, certainly type them in.
Well, I just wanted to pop one more slide up that I actually think is important. So and many of you have probably seen the slide if you've sat in on any of the OIN workshops, but a lot of what this the API structure allows you to do is you can actually have your data transfer nodes out in the Science DMZ, as I mentioned, but you could actually build your app. In most cases, you would be building your app and running it behind the firewall, right? So I could have my code, that's driving Globus running here, right? So it's fully secured. You're doing, SPI and what have you, but the data are still flowing directly on this nice clean data path. So that's another sort of benefit of going this route.
All right, so we're not seeing any more questions come in. I do have one more. I think you have a tutorial or a session at SC17. Can you give a little bit more info about that for people who will be there?
Yes, certainly. So I'm actually going to introduce that session pretty much as I did today, except we're going to dive down into these examples in a lot more detail and actually show you examples of how you automate this based on doing things like running command line apps that can just run indefinitely. So for instance, using what we call refresh tokens, right? So because every time, otherwise you'd have to have people periodically re-authenticate, which doesn't really work if you want something to just run lights out, right? So things like that we're going to cover in that tutorial. Just go to the next level of detail behind some of these scenarios that I sort of glossed over today.
And what day was that going to be?
That's on the Monday afternoon of SC. That's the 1:30 to 5 p.m. session on Monday.
Okay.
Yeah.
All right. Well, thank you so much for doing this, and please send me your slides. I'll make sure that those get posted. For people who want to stick around for a couple more minutes, I have a couple of videos that I just took at SC Staging that I'm happy to show. Next week's talk is going to be the SC17 SciNet architecture team talking a little bit about the network that'll be featured there in 2 weeks. So hopefully everybody can join us for that. So I'm going to stop the recording at this point, but I'll stick around and I'll show the videos after I get done with that. So let me stop the recording.